Let's get started with lesson 9.6. This is the quadratic formula and the discriminant. This is quite possibly one of the most important lessons in Algebra 1. This will be showing up again in both Geometry and Algebra 2. Quadratics show up a ton when we're talking about modeling in the real world, whether we're talking objects in motion, like throwing a ball up and down, or use in architecture or for other modeling. So, let's get started with a start thinking. Let's try to solve the quadratic x squared plus 5x plus 7 equals 0. If we make an ACB, we're looking for factors of 7 that add up to 5. So the answer is we can't do it this way. We can't factor this. There's no factors of 7 that will add up to 5. This is where the quadratic formula comes in. So this is the quadratic formula. And what the quadratic formula allows us to do is it's a way to solve every quadratic equation. It's a formula that gives the solutions to any quadratic equation. And let's scoot this down a little bit. So if we have a quadratic equation, right, that's something in the form ax squared plus bx plus c, that's our quadratic part. The equation means it's equal to 0. Then what the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, this is a confusing formula, but it's actually quite simple to remember. I'm going to give you the tip that Mr. Gallagher gave me when I was learning this, and it's still what I use to remember it now. There's a song that we can use, Pop Goes the Weasel. So you can write it out like this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Use that song to remember this. As a matter of fact, you have an extra credit opportunity. If you record yourself singing that song and turn it in, you'll get a couple of extra credit points. It's the most useful way to remember this, because there'll be a lot of times where you just need this, and it's more of a pain to look it up than it just is to actually remember that. Use the song to remember it. Let's go through an example of how we would use this. Let's find the solutions to the quadratic equation 2x squared plus 3x minus 5 is equal to 0. So let's do a quick check, make sure this wouldn't work with factoring. We have a times c, 2 times negative 5. We're looking for factors of negative 10 that add up to 3. So that would be 5 and negative 2. Let's keep that in our mind because we can come back to this a little later. Let's go through this with the quadratic equation though. What is a? Well, a is 2, b is 3, and c is negative 5. So we have our quadratic equation. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. We have this, and now we can just substitute in the values. So we have negative b is negative 3 plus or minus the square root. B is 3, so it's 3 squared minus 4 times 2 times negative 5 all over 2 times 2. So this is equal to negative 3 plus or minus the square root of 9 plus 40 over 4. Or when we simplify this, that's negative 3 plus or minus the square root of 49 over 4. Square root of 49 is 7, so we can use that. We're going to split this up into two parts, the plus and the minus. So we get x is equal to negative 3 plus 7 over 4. And we get x is equal to negative 3 minus 7 over 4. This one comes out to be, if we go through this, 4 over 4. So that is equal to 1. And if we do it this way, we get that that's negative 12 over 4. So that's equal to negative 3. Now, if we were to use these two values and do the factoring the regular way, we would get these answers. So our answers are x is equal to 1 and x is equal to negative 3. Really, that's all it is. The hardest parts about this lesson are doing the actual calculations and remembering the quadratic formula. Now, why do we want to use the quadratic formula when we can just factor it out? Well, the quadratic formula can be used anywhere, which means it can also be used with ugly numbers. Like, let's say we're looking at a baseball that was hit, right? Went up to bat and you hit a baseball. The height of that baseball, let's say y is height and x is time, would actually be represented in meters as something like y is equal to negative 4.9 x squared plus 6.5 x plus 2. Now, these are ugly numbers. They're not going to be ones we can factor, but if we use the quadratic formula, we can allow our calculator to do all of that. So let's run through what this looks like. We're looking for the time until landing, right? If we want the height to be 0, the time until landing. So what if we're looking for the time until landing? That would be where y is equal to 0. So we get 0 is equal to negative 4.9 x squared plus 6.5 x plus 2. Now we have this equal to 0, so we can start solving. A is going to be negative 4.9, B is 6.5, and C is 2. Let's put this into the quadratic formula. X is equal to negative, B is 6.5, plus or minus the square root of B is 6.5 squared minus 4 times A is negative 4.9 times 2. And this is all divided by 2 times A, which is negative 4.9. So we now put this into our calculator and let it do the work. This comes out to be negative 6.5 plus or minus the square root of 81.45 over negative 9.8. Now, we have something that's not an easy square root here, so we're going to take the square root and figure out what that's equal to roughly. Our calculators, when we put that in, will tell us this is approximately 9.025. So let's use that for our number. So we get x is equal to negative 6.5 plus 9.025 over negative 9.8. Right, that's the positive, that's the plus here. Or we have subtraction, so it's negative 6.5 minus 9.025 over negative 9.8. And from there, we can just put these into our calculators. Remember to put parentheses around the top of this before we put it in. And what do we get? We get x is equal to roughly negative 0.258 seconds, or x is equal to roughly 1.584. Now let's look at these and figure out what makes sense. We said x is the time that it takes, right? So if we're saying that the time that the ball hits the ground is negative 2.58 seconds, we're saying that it happens before we're actually looking at. So that doesn't actually matter to us. Doesn't make sense, right? How would we know what's happening before the bat hit the ball? So instead, our answer is going to be this. This is really all we're doing with the quadratic formula. We get some values, we substitute them in, and we work through using our math abilities and using our calculators until it works. So now that we have done this, we have 4 different ways we have of solving a quadratic. Let's go through each of them and talk about when it would be useful to solve this way, or when it would be useful to use these. So let's go through our ways we have to solve a quadratic equation. First off, we started by looking at graphing, right? We put something in, we look for the x-intercepts, set it equal to 0, we look for the x-intercepts, and those will be our solutions. So when is it useful to graph? Well, it's useful to graph when it's easy to graph. When you have a graphing calculator. But we also ran into another problem, right? We can't really determine what this is unless your answers are on the grid, right? They're part of the grid. So graphing is useful when you have a graphing calculator and when you can figure out your answers easily, when they show up at an actual value. Next, we have the square root. Square roots. When is it useful to use the square root? Well, you can't have x terms. So you can't have anything in the x to the 1 power for you to use the square roots. Then we have factoring. When should we use factoring? Well, we should use factoring if you can factor the equation easily. You can factor the equation easily. So if there's no a value, or if it's something that we can factor quickly, we should do that. What about the quadratic formula? Well, this is your catch-all. I'm going to shorten this to quad form here. So you can use this when you can't factor easily or it can't be factored. So if you can't factor, you should use the quadratic formula, or if it looks like it's going to be messy to factor, you should use the quadratic formula. So keep this in mind when you're looking at quadratics. You can solve them by graphing, by square roots, by factoring, or by quadratic formula. If we were to have a quiz or a test, there would be some problems where you can use whatever question or whichever method was the simplest for you. It's not going to be that, so let's make sure that we just remember these. Now, we said this lesson was the quadratic formula and the discriminant, so let's talk about what the discriminant is. Your discriminant is defined as the part of the quadratic formula under the square root. What's the quadratic formula? X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So the part underneath the square root here is your discriminant. B squared minus 4ac is your discriminant. Discriminant. So Why is the discriminant useful? Well, it tells us the number of solutions that we have before we actually have to do any of the hard work of taking square roots or looking at plus or minuses. So it allows us to easily determine the number of the solutions we can have. Let's look at all of what the discriminant can tell us. So there's three different options for what we can have for the discriminant. The first one is that we have a discriminant where our discriminant b squared minus 4ac is greater than 0, or it's positive. What does this tell us? It tells us that the number of solutions will be 2. So what would be an example of this? Well, let's say we're looking at x squared minus 6x plus 7 is equal to 0. The discriminant would be b squared, so negative 6 squared, minus 4 times 1 times 7, or 36 minus 28, so we get that this is a positive 8. That means that this will have 2 solutions. The next potential, if we have this is greater than 0, is we can have it that our discriminant is equal to 0. b squared minus 4ac is equal to 0. What does that mean? That means we have one solution. And this would look like something like x squared minus 6x plus 9 is equal to 0. Put that in for your discriminant. You get negative 6 squared minus 4 times 1 times 9. So this becomes 36 minus 4 times 9 is 36, or 0. That would tell us that this would have one solution. And our last option is going to be our discriminant b squared minus 4ac is less than 0, or it's negative. What happens if that's the case? Well, we know that we have no solutions. So this would be something like x squared minus 6x plus 11 is equal to 0. Your discriminant is b squared is 36 minus 4 times 1 times 11, or 36 minus 44 would give us a negative 8. So negative 8, our discriminant is negative 8. We have 0 solutions. If your discriminant comes out positive, 2 solutions, 0, 1 solution, or negative, no solutions. Now that's all we have for the lesson today, so we have some practice problems here. So again, it's important that you do these, especially for this one, because got to make sure you know where there might be issues when you're actually doing the math. So the first one, you're going to solve using the quadratic formula, 4x squared plus 7x minus 15. And you're going to solve 3x squared plus 5x is equal to 4. And then for the third one, I want you to tell me the number of solutions. How do we know the number of solutions? Well, that was what the discriminant was for. So what number of solutions are we going to have for the equation 9x squared plus 12x plus 4 is equal to 0? All right, go ahead and pause these and we will return once you're finished and go through these. All right, let's get to it. Starting with this one, we have a is equal to 4, b is equal to 7, and c is equal to negative 15. Quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we get that this is equal to negative 7 plus or minus the square root of 7 squared minus 4 times negative 15 all over 2 times 4. Or this is equal to negative 7 plus or minus the square root of 49 minus 4 times 15 So we get minus a negative 240, so we get plus 240 over 8. So 49 plus 240 gives us that this is the square root of 289. So we're looking at negative 7 plus or minus the square root of 289 over 8. Let's see what the square root of 289 is. Well, that's 17. So this is equal to negative 7 plus 17 over 8, or this is equal to negative 7 minus 17 over 8. So this becomes negative 7 plus 17 is 10 over 8, or when we reduce that, that becomes 5 over 4. Or we get x is equal to negative 7 minus 17 will give us negative 24 over 8, or negative 3. So our answers are x is equal to 5 over 4, and x is equal to negative 3. If you put those back in, you would see that this does come out to be 0. Let's go through with the next one. So first, notice that we don't have this equal to 0. The steps for solving an equation still are important. We have to get that 3 or that 4 over to the other side before we can begin. Now that this is equal to 0, we can solve. So we get a is equal to 3, b is equal to 5, and c is equal to negative 4. So we get x is equal to negative 5 plus or minus the square root of 5 squared minus 4 times 3 times negative 4, all over 2 times 3. Or this becomes negative 5 plus or minus the square root of 25. Negative and a negative will cancel out, so this is plus 4 times 3, which is 48. Over 2 times 3 is 6. So 25 plus 48 is 73. That's not going to be something that has a nice square root, but we have our calculators here, so we can just approximate that. So we have x is equal to negative 5 plus or minus the square root of 73 over 6. That's supposed to be just a 6 there. All right, and what's square root of 73 roughly equal? Well, that's about 8.544. So let's split this up. We get x is equal to negative 5 plus 8.544 over 6, and we get x is equal to negative 5 minus 8.544 over 6. So this becomes x is equal to negative 5 plus 8.544 is 3.544 divided by 6. That becomes x is about equal to 0.591, and we get x is equal to negative 5 minus 8.544 is negative 13.54. Divide that by 6, we get that this is roughly negative 2.257. So those are your answers for the second practice problem. And then for this third one, we are looking for the number of solutions. So we're going to use the discriminant. Remember, the discriminant is b squared minus 4ac. So our discriminant is 12 squared minus 4 times 9 times 4. 12 squared is 144, and 4 times 9 times 4 is 144. So we get this is 144 minus 144, or it equals 0. So if this equals 0, how many solutions do we have? We look back up here. If it equals 0, we have one solution. So our answer is we have one solution. All right, that's all for today's lesson. Go ahead and get working on the homework.